Okay, in this last portion of 4.3, we will be talking about composition of inverse trig with sum, difference, and double angle identities. So those sum and difference formulas are not going away. So what you have to consider is that you may have a sum, a difference, or a double angle. Okay? And that would be in your inner function. So again, we have a series of strategies that we can use. So we'll make an equation again with the inner function. And what we'll do is set it equal to alpha and beta for our sum and difference, and we'll set it equal to theta for double angles. Okay? So what we're going to do is then draw a reference triangle for the appropriate quadrant. And just as a reminder, these will be numbers. Okay? We'll find our missing side using the Pythagorean theorem, and then when we get to where we need to get to, we will use either the sum, difference, or double angle identity. Then we'll simplify the problem by reading the values from the appropriate reference triangle. Okay, so in the video, in here, I'm going to do, in this case, a difference. In class, we'll do a double angle. So, first of all, we're going to call this first one, so let me highlight this. Alpha. So this right here is going to be my alpha. And this right here is going to be my beta. So this is alpha minus beta, and this is cosine. So what we have here is the cosine of alpha minus beta. So if you remember, the identity is the cosine of alpha, cosine of beta, plus sine alpha, sine beta. So we're going to need some values, and this is where we're going to use these triangles. So first of all, inverse tangent, positive, first quadrant. So we'll draw our reference triangle in the first quadrant. Okay, this is y over x. So this is not one of our common triples. So this is 2 squared plus 1 squared is equal to r squared. So this would be the square root of 5. Okay, and remember, this is our alpha. Okay, then inverse sine, negative. That means we're in the fourth quadrant. So I'm going to draw my reference triangle for beta. This is beta. Let's see, this is -3, this is 5, so this would be 4. This is a common triple. Okay? So now, if this is my alpha, I need both sine and cosine from alpha. So my cosine from alpha, okay, remember, is x over r. X over r. Okay, so we have 2 over the square root of 5. This is coming from this reference triangle. Cosine beta. Okay, x over r, 4 over 5, plus sine alpha. So this is y over r times sine beta, -3/5. Okay, so really we're using these to find our cosine alpha, sine alpha, and beta. Multiply. Oops, -3 over 5 square root of 5. They have a common denominator, so this is 5 over 5 square root of 5, which is 1 over the square root of 5. So when I rationalize, I end up with square root of 5 over 5.